Good afternoon, everyone. Myself Yagyapal Yadav, Computer Engineering Department, Assistant Professor, IPS Academy, Institute of Engineering Science. So, today we study set theory. So, first, what is set? Set is a collection of objects or elements. For example, like A is a set, the collection of 1, 2, 3, 4, or A, B, C, or A, E, I, O, U. So, it is a collection of sets. Next, how to represent the sets? So, we can represent the set there are two forms of representation. First is a tabular, or it also known as roster, and second is set builder. In roster tabular form, the set will be represented in the table form, like you have a set A with the elements 1, 3, 5, 7, 9, 11. So, this is just a simple tabular form. Each element is separated by the comma. Another example is 2, 4, 8, 10, 12. So, this is the tabular or roster form. Next, the set builder form. Set builder form, that means you must need the property of the element. One thing you understand here, that the property of each element is same. That means each element should possess the particular property. If any of the element is not possess the particular property, then you cannot write the set builder form of that particular property. For example, I need to write A, X is the element such that X is the element of vowels of English language. So, here you can say A, E, I, O, U. So, each element is a vowel of English language. So, set builder form is just like each element possesses the particular property. You just write the property. So, what is the use of these two? If your set is countable, that means you can count the set, or you can come to the ending of that particular set. You can just see the last element of the set. You just write a tabular or roster form. But if you have a property and the elements are infinite, there is no ending element you see or you can write. So that in that condition you write the set builder form. The next thing, some like set of natural numbers represented by n, which are 1, 2, 3, 4 and so on. Now, whole number is represented by W. It contains 0, 1, 2, 3, 4. This is the difference between natural number and whole numbers. Next is a real number, R, represented by having both the integer part as well as decimal part, integer and also decimal part. These are the real numbers. Q is the rational number, like P by Q, okay, where P is the element of and Q is also the element of I, but there is also and Q is not equals to 0, because if Q is 0 then it becomes a not possible in mathematics. That's why the Q you must, this is called a roster form. This is called a set builder form, because you cannot find the last value of that rational numbers. That's why it is called a set builder form. Now another one is a complex number, is represented by Cx plus Iy. This is the set of complex numbers. X is the element of I and Y is the element of I. Okay, so this is called a complex number. So this is general terminology of we are using in the sets. Okay, next we start with the operations on a set. There are some operations. First we start with the different type of sets. Types of sets. So number one, empty set. That means a set contains nothing. So empty set represented by simple curly brackets, or it's just a phi. This is known as the empty set. Second thing, singleton set. Singleton set, the set contains a single value, only a single value, like this. This is the singleton set, like one only. This is the singleton set. The third one is finite set. The set, the values in the set is a finite. That means you can count the values, you can reach to the last value. For example, there is a set A, then there is 1, 2, 3 and 4. This is the finite set. You can count the values. One set builder form for finite values like x, where such that x is between 7 and x is the natural number. Okay, so this is called a finite set. Second is a infinite set. So infinite set we also saw before. You cannot reach the last value of the particular set. So this is called an infinite set, like n, r, q, c, I. This is the infinite sets. The fifth one is subset. So this is more important, because in the further lectures you know the subsets. It's mostly used in the set theory. So let there be two sets A and B. There are two sets A and B. So if every element of A, if every element of A is in B, then it is called A is a subset of B. Then it is called A is a subset of B. If every element, it is not required that every element of B is in A, but every element of A is in B, then called A is the subset of B. When every element of B is in A, then you can write B is a subset of A. So in notation form, it is just like A is a subset of B. This is the notation for subset. Clear? Then there are some notation points. If A is not a subset of B, then it is write like this. So this is A is a subset of B, and this is A is not a subset of B. There are some notation points like empty set is a subset of all sets. That means whatever the set you see here, like for example there is a finite set. If you want to find the subset of these finite set, there must be a infinite also. That means infinite, sorry, phi. Phi is a subset of every set. Phi is a subset of every set, and empty set is a subset of itself. If you write an empty set, like A is an empty set, if you want to write the subset of A, then empty is also the subset of A. That means subset is a subset of itself. Empty set is a subset of itself. Now next, proper set. Now next is a proper set. So what is, sorry, proper subset? Proper subset. Now let there be a two sets like A and B. There are two sets A and B. A is a subset of B. First thing, there are two properties to become a proper set. First, A is a subset of B, and second thing, there exists, that means there exists one element, at least one element in B which is not in A. So A is a proper subset of B if A is a subset of B, that is okay, that is A is a subset of B. And second thing, there exists at least one element which is in B but not in A. Clear? So by the notation you can write A is a proper set of B. So this sign is proper set and this sign is for subset. Just note it down, like this is the subset and this is the proper set. Don't confuse in between subset and proper set, subset. So read A is a proper subset of B. Clear? When A is a proper subset of B, then B is called a superset. If A is a proper subset of B, then B is a superset of A, because B contains the element which is in A but also some elements which is not in A. That means there is a whole bunch of something. You just put the one thing from that particular thing. That means this is the proper subset of this particular thing, but the B is the superset of A. You can write it like this: B is a superset of A. So this should be write it like this: B, इसी को अगर मैं उल्टा कर दूँ like this, then it becomes B is the superset of A. So you read this notation as B is a superset of A, and this notation B, A is a proper subset of B. Now next, improper set. So improper set, the set which is not proper is called a improper set. That means every set is an improper subset of itself. The set is an improper subset of itself. For example, you can take the example of it. Okay, you can take the example of, like, A is a set like A, B, C and D. So A is a subset of A. Yes, definitely A is a subset of A because all the elements of A is available in the A. So this is called A is a subset of A. But A is an improper set of A because A contains A, B, C, D. And again you write A is contained A, B, C, D. These are the elements in A. But the proper subset is what? When it becomes a proper subset, then what? There exists at least one element which is not in A. So A all the elements which is available in A is also available in A, right? So it is improper improper subset. Now next is a equal set. The next is a equal set. So equal set, two sets A and B are called equal. A equals to B are equal when every element of A is also the element of B. Every element of A, for all element of A is in B, for all element of B is in A, right? So you can write A is a subset of B and B is a subset of A. When this belongs, these two sets are equal. Then this belongs, A is a subset of B and B is a subset of A, then you can write A equals to B. Clear? So next, let's clear it. Next is a power set. Next is a power set. So what is power set? Let there be a set A, B, C, D. There is a set A, B, C, D. A set A contains element A, B, C, D. Then the power set of A is denoted by P of A. All the subset of A is called a power set. That means the power set contains all the subsets of A. So all the subsets of A is what? It contains, you already know that the empty set is the subset of itself and every set. Empty set is also the subset of every set. So this A, then B, then C, then D, then A comma B, A comma C, A comma D, B comma C, B comma D, C comma D, then A, B, C, D, and all the combinations of these four is called a proper set of A. Power set of A. Power set of A denoted by P of A, then empty, and all the subsets of A is known as the power set of A. Okay. Next thing is universal set. Universal set, universal set like N, R, Q, C, these are the universal set. Because हम कोई भी set builder form लिखते हैं तो उसके अंदर हम लिखते हैं X is the element of R, X is the element of N. But in our term, when we are solving some questions and all these things, the universal set is something different. You think about that. These are the universal set, definitely these are the universal sets. But when you are talking about the problem solving in discrete structures, set theory, you think about that the universal sets are just like, if you have a set U or any set, whatever, not U, it is for A, and A contains 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This is the set A, and you are taking the any subset of A. So any subset of A, for example, there is 2, 5, 6, 8. This is the one of the subset of A. So A is the universal set for B. A is the universal set for B. You can say that A is the universal set for B. You can treat A as a universal set for B because B contains the value which are already in the A. So this is called a universal set. Now next is a set of sets. Set of sets. So this is the set of set. You already see here The power set is also the collection of set, because the set of set is that every element is treated as the one set of the particular set. For example, A, B, C, D, then A, so A is a set, B is a set, C is a set. So this is the collection of set. A particular set is the element of the set A. So this is called a set of sets. You can also say this is the family of sets. Family of sets. The family of particular set is called a set of set. Now next, one important last type of set is index set. Index set. So for example, let there be a T which is non-empty. Index set should be always a non-empty set. T be a non-empty set. Then there are set of each element of T. There are set of each element of T. You can write it like this. For example, you can write T is the element of T. For example, a set A contains A, B, sorry, it is not A, it should be T. T is A, B, C. Then there is a set of C of A, there is one set of C of A, one set of C of B, one set of C of C. So there is a different sets for each. So this is called the index. So T is called the index set, and this A belongs to T. That means for all element of T there exists a set. T के जितने भी elements हैं उन सबके लिए एक set exist होना चाहिए. That means this is called a index set. Now next we start the operations of set. So some of the operations. Operation of sets. So number one, union of sets. Union of sets. So let there be a two sets A and B. There are two sets A and B. The union of set is denoted by A union B. Okay, the union of sets is denoted by A union B. Is a collection of all the elements which are in A or in B. ऐसे elements जो A में भी हों या फिर B में हो, किसी में भी हों, these elements are come into that union part. You can understand with the example. Like for example, set A contains 1, 3, 5 and B contains 2, 4, 7, 8. So what is the union of A union B? What is the result of A union B is 1, 2, 3, 4, 5, 6, 7 and 8. This is called a union B. All the elements of A or all the elements of in B. Clear? So this is you can write the roster form of union is A union B equals to X, where X is the element of A or X is the element of B. That means X या तो A का element है या फिर B का element है. It is available in the A union B. Result of A union B. So this is the example. Next is a intersection of sets. Now let there be a two set A and B. There are two sets A and B. The intersection is denoted by A intersection B. The elements which are available in A or and in B. The intersection is known as X is the element where X is the element of A and X is the element of B. You see there is an AND, there is not OR. OR that means either available in A or available in B. But the X is only the element which is available in A and in B. That means the element which is available in both is only the result of A intersection B. For example, if A contains 1, 2, 3, 5 and B contains 2, 5, 7, 8, then the A intersection B is only what? 2 and 5. This is the A intersection B. Clear? Then next is disjoint. Disjoint sets. The next is disjoint sets. So what is disjoint sets? A and B are two sets. A and B are two sets. These are known as disjoint if A intersection B is phi. If A intersection B is phi, then the two sets are known as the disjoint set. That means nothing of the element of A is matched with the element of B. There is no element which is available in A also available in B. The common elements, there is no common element in A and B, then A and B is known as the disjoint sets. Now next is a difference of two sets. Difference of two sets. That means there are two sets A and B. The difference is denoted by A minus B or A difference B. The difference in that order of the set of element. There is a order is important in the difference of the element. If you write A minus B is different, then it is not equivalent that B minus A. So what is difference? That the element, if you write A minus B or A difference B, the element X which is available in A and X is not the element of B. Only those elements which are available in A but not in B is known as the A difference B. If you write B difference A, the thing will be changed, like B difference A is thing will be changed like this. X, where X is the element of B and X is not the element of A, and X is not the element of A is known as the B difference A. Okay, so this is called a difference of sets. Difference of two sets. So these are some type of set, operations of set. Some operations are there in the sets like union, intersection and all this. Now there are one more representation of sets. We see two type of representation of sets here. One tabular or roster form and second is set builder form. And there is one another representation is called a Venn diagram. There is also a one representation called a Venn diagram. So you can write, you can show the sets with the help of diagram. So Venn diagram is called like there is a square is called a set, a collection of set. That means a universal. It is also always a universal set. This square is also always set as a universal set. In this universal set there are sets which we need to show. So if you need to show a set A and set B, there is set A and there is set B. This is called a Venn diagram of two sets A and B. Both are different, maybe possible their elements are common or not. We will represent it in the form of like this. If you want to represent the A union B, that means the element of both the sets. So it shows like this. So this is called a union B. Some elements are different in both, some elements are common. So this is called a union B. If you denoting the A intersection B, then in the Venn diagram it should be denoted by like this. This is U, this is A, and this is B, and this is called a intersection B. So this part should be, this middle part should be the intersection of A and B. So this is the representation, another representation of Venn diagram of sets. You can write the representation in tabular form, roster form, or set builder form, or a Venn diagram. So this is the representation. Something some special operations on set we see here in next part. The operations we see right now or till now are the basic operations, but there are some special operations of set which we need to understand. First thing, two things you need to know, that countable set and uncountable set. So countable and uncountable, right? So countable is definitely the set where the elements are belongs to natural number or some range like 1x8. So this is the countable set, because you reach the end of the set and you find the last value of the set. This is called a countable. When set is not countable, then it is known as the uncountable. Like if you cut this out, x and this, then this set is uncountable. But if you give the value like this, x is belong between 1 to 8, then it is known as the countable set. Now the most important topic, principle of inclusion and exclusion. This is the important topic of set theory. Principle of inclusion and exclusion. Principle of inclusion and exclusion. So we have a union B equals to A plus B minus A intersection B. That means we have two sets A and B, so you can write it like A union B, the set of A plus set of B minus A intersection B. That means the element of A, all the elements of A, all the elements of B, but there is not the element which are common in A and B. So this is called the principle of inclusion, because these elements are repeated. If you put these element also there, then there is a repetition. So we need to find that the repetition should be null and void. There is no repetition of the elements in the process. That's why we think about that, the principle of inclusion and exclusion. So we see with that with the example, you can also so what is the formula is that A plus B plus C plus A, sorry, it's not plus, it should be minus A intersection B minus A intersection C minus B intersection C plus A intersection B intersection C. Okay, so this is called a principle of inclusion. We can see with the help of example. So we see the example of it. So we have example of, you already heard about that example. There are some student in that group, some student in that group. So I have an example like, there are total athletic team in the college, 21 athletics team in the college. Total 21 athletic team in the college. 21. Okay. Sorry. Athletic team in the college. कितनी एथलेटिक टीम है कॉलेज में? सो 21 फुटबॉल, sorry 26 is football, 21 is basketball, and 14 is 29 is hockey. 29 is in hockey. So this is not team, this is actually players. There are athletic players. So 26 players in football, 21 players in basketball, and 29 players in hockey. Okay, some more part of it. 14 players play basketball and hockey. Basketball and hockey. 12 play football, basketball and football. And 15 play hockey and football. Okay, so there are different type of players. 26 play football, 21 play basketball, 29 hockey, 14 players play both basketball and hockey, 12 players play basketball and football, 15 players play hockey and football. They play both the players, and 8 play all 3 games. There are 8 students which are play all 3, football, basketball and hockey. Then we need to find the players. There are number of players, there are all in, that means they play all. हमको ऐसे players find out करने हैं. Find the number of players there are in all, जो कि सभी में है. So we need to find it like this. There are, ये हटाना है हमको बस कुल मिला के, ठीक. सो वी नीड टू फाइंड इट लाइक दिस, ए यूनियन बी यूनियन सी, वो ये निकालना है इनका तीनों का. सो डिफरेंस निकालना है. सो वी नीड टू फर्स्ट फाइंड ए, ठीक, देन फाइंड A1, देन A2, देन A3. सो यू कैन राइट इट लाइक दिस, A1, A2, A3, and put it like this. So you just put into the formula A1, A2, A3, and then minus A1 intersection A2 minus A1 intersection A3 minus A2 intersection A3, and then plus A1 intersection A2 intersection A3. It's very simple. So A1 is what? The 26 players play football, the player play basketball, the player play hockey. This A intersection B, so basketball and hockey, hockey and football, football and basketball, and then this is all three. So you just put the values and you will get the answer. Like if you put that 26 plus 21 plus 29 plus 14 plus 12 plus 15 minus 8. So you will get that answer. What is the? So this is called the principle of inclusion and exclusion. So this is for today all. So here we see set theory, some basic sets are there, natural numbers and all these things, some types of set, the operations of set, and the one of the principle called the principle of inclusion and exclusion. Okay.